It's good. All right. So so we're going to break apart into H plus and HCOOH. Nope. Come here. HCOO minus. There we go. So we're going to basically employ our normal ice table here. We're going to start with 8 molar, which was originally given to us. We're going to go 0 and 0 in this particular case. And change is going to be minus X plus X plus X. That means at equilibrium, 8 minus X, X, and X. Now we could write our Ka expression here, which would be our H plus and our HCOO minus divided by our HCOOH. And that equals, I'm not sure, because that's what we're looking for in this particular case. So we normally would just take all these guys and put it into here and try to solve for X. But in this case, we don't know what all these guys are. So we can use the other piece of information that's given to us, and we could use the percent ionization to help us out. So as we saw earlier there, the percent ionization is the concentration of H plus divided by the initial concentration of the acid, which is with a little 0 there means, times 100%. So they told us that it is 0.47% ionized. H plus we don't know, but we do know that the initial concentration was 8 molar times 100%. Now, if I multiply the 8 to the other side and divide by 100, that is going to give me my H plus concentration. So if I take 0.47 times 8 divided by 100, it is going to give me my H plus concentration, which in this case would be 0.0376 molar. And again, I got that for solving for H plus here using the percent ionization. You may be asking, why is that important? It is important because if we look at our ice table, the H plus concentration equals X at equilibrium. So because we now have been able to figure out the H plus concentration, we actually know what X is. And this X here is the same X as this guy, and it's the same X as this guy as well. So we now have all of our X values by using the percent ionization. That means that we can take our concentration of HCOOH would equal 8 minus X, which would be 8 minus, what do we get there, 0.0376 molar. And that would get us, we'll call it 7.9624. I'll just keep all the numbers for now. We also found our H plus is equal to X, which would be 0.0376. We also saw that our HCOO minus from the table is equal to X, which would also be 0.0376 molar. So by using that percent ionization, we were able to figure out now the equilibrium concentrations of everybody. And now we could actually put in numbers for our Ka, which would be our products, which would be X squared divided by 8.0 minus X, which in this case would be 0.0376 squared divided by 7.9624, going to get us a Ka value of 1.8 times 10 to the minus 4 in this particular case. So in this case, we were able to use the percent ionization and the initial concentration of acid to sort of work backwards to actually figure out the H plus concentration, which based on our table was X. and also allowed us to figure out the Ka value, because once we figured out H plus, which was X, it is all the X's in the tables and allows us to get the Ka value. Question on that calculation there? Question on anything we talked about today? Okay, so we will stop there for today's lecture. A reminder that Thursday is exam day, so we are going to have a short lecture to begin with at normal time. We will stop early, and then the exam will be available, much like the quiz was, using Proctorio on Canvas at the start of lab at about, 11:30? And we'll do that. For today's lab, we're continuing on with the equilibrium one. So last time we talked about part 1. We will talk about part 2 today, and sort of the idea behind part 2 and sort of the calculations and stuff that you need to do. And then you could continue to work on that. Any questions on any of that? All right, make sure you put here if you haven't done so, and I'll see everybody in about 20 minutes in lab.